Introduction. All this may seem very close to fiction, but the artificial intelligence is already present in the daily lives of all people. For example, in the development of video games that use this type of study to create more complex games. In football games, each player has very specific and similar characteristics to those of a real competitor. That is, one is better to pass, but runs less than the other. The intelligent systems techniques are applied to simulate this action. Another example is the cameras that make the autofocus on people's faces, or shooting to find a smile. Even in spell checkers of computer word processors, an intelligent system is necessary to detect that there is a syntax problem in the sentence and provide a possible fix. Many people complain that the broker always errs, but we must remember that as intelligent systems simulate the human, they make mistakes like us. This ebook is designed for you to have many questions about a subject so controversial that arouses an enormous curiosity about the world, but also frightened. Chapter 1. Artificial Intelligence. History. The term artificial intelligence was created in 1956 upon the occasion of the important meeting at Dartmouth, where they met minds like Alan Newell, Herbert Simon, Marvin Minsky, Oliver Selfridge, and John McCarthy. At the end of the 50 born the symbolic processing, with a result of efforts Newell, Simon, and J.C. Shaw, that instead of building systems based on numbers, engineered systems capable of manipulating symbols. Thus, the different currents of thought in artificial intelligence, now called distributed intelligence, have studied ways to establish on the machines intelligent behavior, which could be easily expressed by Minsky in the book Semantic Information Processing. How do computers understand things? The term artificial intelligence can refer to an entire universe of programming techniques used to try to solve problems more efficiently than algorithmic solutions and the closest to the intelligent human behavior. Main technical. They stand out in the large family of techniques of artificial intelligence the following research fields. A. Natural language, which addresses a set of techniques aimed at the recognition and generation of natural language, written and spoken. The main applications are in the field of universal translators, editors, and the mining of texts and controls voice devices. B. Automation and robotics, i.e., the set of technological resources that aim to create autonomous robots, able to learn and make decisions. Many of these systems are already in operation, and have been reported here in Hyperscience. C. Perceptual systems, which aim to create visual pattern recognition systems, sound, and textures to simulate and enhance the perception, whether optical, hearing, or touch. Its main applications are in the medical diagnostic field and industrial quality control. D. Expert systems, which capture the knowledge in defined areas of knowledge and human experience, using it in decision-making. Observe currently important applications in medical diagnostics, identification of chemical compounds, and in decision-making processes of business managers and brokers in the stock market. A special feature of expert systems is the occurrence of systems that support the decision in case-based reasoning. E. Genetic algorithms, which consist of several troubleshooting techniques based on the principles of Darwinian evolution, or mutation, breeding, and selection. They are used to solve problems involving a large number of variables and calculations, such as the fairings aerodynamic projects developed by aerospace and automotive industry. F. Intelligent agents that characterize the set of standalone software that works in networks, or in parallel to a primary software created to achieve predictable, precise, and repetitive tasks. For example, operating systems, software that manage email, and network tools are hosts for intelligent agents. Noteworthy is its primary applications in the management of large volumes of information, such as, for example, in the stock market, in search engines, and the Internet in the monitoring and management of e-commerce. G. Neutral networks, which are simulations of the human brain processing patterns, such as plasticity and learning. Has its architecture based on an approximation of the animal brain, and instead of being present, the neural network learns a particular training environment. Its construction is based on perception, a discrete component that tends to simulate the physical behavior of a neuron. The association of thousands of perceptions obtained enough plastic networks, which can recognize complex patterns, such as cracks in metal welds in pipelines, or quality of an apple, diagnosed by color patterns of its bark. In this book, we will talk about artificial intelligence from the time that we would never think that such a concept existed. Chapter 2. The artificial intelligence is older than you think. The area is divided into two parts: AI symbolic, which is connected to the psychology, and the connectionism, or artificial neural networks, which comes from neurophysiology. The latter, for reference, was that Google mentioned when he explained how the AlphaGo, Al Robot Deep Mind, trained to play Go. Computer science is a new field of study, but not artificial intelligence. It is beyond the Greek philosophers of Plato, of Aristotle. It is very interesting to observe these scholars of the past. They will reassemble and building what we understand today as a scientific model. Not today we address tools of artificial intelligence in Technoblog. We see Google leveraging technology to beat world champions' complex board games and even combat Aedes aegypti. Microsoft has signaled several investments in the area, either with human capacity or application of Microsoft research. What few people know is that it is one of the old news, being idealized in time to before Christ. Artificial intelligence, although much more palpable today, comes to the Greek philosophers and had a breakthrough also in the 20th century. To understand what exactly this term, we need to turn to the origin of artificial intelligence. It is an area of computer science in which researchers sought different realities of an only programmatic model, not to solve simple problems such as adding two numbers, intending to create a kind of thinking in computing. Artificial intelligence in antiquity. Not that existed systems that did things for themselves, but the idea of a non-human intelligence that thought itself was already conceived according to the professor. He says Aristotle, teacher of Alexander the Great, king of Macedonia in ancient Greece, thinking about how to free the slave of your business. The slave was treated like nothing in the social aspect. He imagined the following: is an object like a broom, or an element that makes cleaning, can have an own will and establish the storage system? Thus, we would not need more than slave labor. These guys saw that it was not cool to have this domain and sacrifice of another human being. He invented robotics in 300 BC. Philosophers were asking things like, will a slave in possession of innate information, which come with the nature of man, could learn math? Of course, yes. The revolutionary is the line of thinking because they have idealized cognitive science, which deals with human learning. Chapter 3. Development of Science. The 50 can be considered the time of the golden years of artificial intelligence. There was a psychological chain called behaviorists who treated science as only the act of human behavior. His hand holding a doorknob turns because you want to open the door, for example. According to the doctor, this is not a good explanation. I have to have information processing, which is what cognitive science does. It is not only an input box, input and output. I wonder what's in here, the box. It is what artificial intelligence studies. Know what's in this big box. Artificial intelligence branches in many areas, from games to philosophy. We can imagine this science as a significant capillary, which can be applied mainly at all. The key, then, is to understand that artificial intelligence is one, but its reach is huge. Fernando works in this area for 40 years, going from music and computing in the 90s to a homodynamic description of the functioning of the heart with the lungs in 1983. This concept of artificial intelligence has been well established for several years. What we know today as artificial intelligence was detailed in a congress by Professor John McCarthy of Stanford University. He began using the term in the conference made from Dartmouth College in New Hampshire. At the time, there were already several theories of complexity, language simulation, neural networks, and learning machines. He decided to give the name of artificial intelligence to those of human imagination systems that use computer science. Several engineers, mathematicians, psychologists, and neuroscientists participated. The capacity and electronic functionality doubled every 18 months, an almost exponential growth that almost kept up. Participants of the Congress left there believing that one day computers would be able to be as smart as humans. Well, it has not happened yet. Still, McCarthy made great advances in his laboratory, one of the first dedicated to the development of artificial intelligence. He won the Turing Award in 1971, given the computer scientists who have made outstanding contributions to the area. Fernando points out that this award is basically the Nobel of computer science. Turing Test. The name comes from the mathematician Alan Turing, portrayed in the movie Game Imitation. Turing is also one of the forerunners in the area of artificial intelligence, according to Fernando, as the mathematician working with complexity. Turing was responsible for accelerating the process of breaking the Enigma machine code to understand how the Germans communicated during the Second World War. Another fascinating work, which also came from him, was the Turing Test. You stand in front of a teletype and do not know what that tells you, and you are a man or a machine. If you cannot know how to identify whether it is man or machine at the end of the conversation, the robot passed the Turing test. In 2014, a group of Russian researchers created the Eugene Gustman, a robot that is a boy of 13 who barely speaks English. He tricked the judges and ended up winning the Loebner Prize, which is given to those who pass the Turing test. However, many experts are skeptical about the achievements of Russian researchers. Instead, they make a high-level Turing test, and they created the low-level test. It is a Ukrainian boy who barely speaks English, and the test is being done in English. When he curls up on the process, he says he is only a child of 13 years and cannot respond very well. In other words, it's easy to fool the judges when you reduce the parameter of the robot can do. You cannot reduce the complexity of the problem. I'll fool people there. We'll pass the Turing test with a limitation. But the limitation is the Russians, and not intelligence. What we want is much higher. The Turing test has used today. According to the doctor, he must have served as inspiration for Microsoft Make bot framework, for example. Everything lies in the central core, the Turing test. How does he do to achieve this? It could use technologies based on psychological systems, or artificial neural networks. Artificial neural networks are recognition machines, which check if it passes through the machine learned. It is estimated that only 20 years from a machine will be able to deceive man. When asked if the bot framework Microsoft could pass the Turing test, it shows disbelief. Not necessarily. Further learning this way, asking for a human when he does not know. What exactly is artificial intelligence? According to Elaine Rich, although most attempts to define precisely terms' complex and extensive use is exercise in futility, it is necessary to outline at least a rough border around the concept in order to have an idea about the discussion we'll follow in Chapter 4. To do this, we propose the following definition, although it is not universally accepted. The artificial intelligence, AI, is the study of how to make computers perform tasks that when people are better. The term artificial intelligence was born in 1956 in the famous meeting in Dartmouth. Among those present at this meeting included Alan Newell, Herbert Simon, Marvin Minsky, Oliver Selfridge, and John McCarthy. In the late 50s and early 60s, scientists Newell, Simon, and J.C. Shaw introduced the symbolic processing. Instead of building systems based on numbers, they tried to build systems that manipulate symbols. The approach was powerful and was instrumental in many later works. Since then, the different currents of thought in AI have been studying ways to establish smart behavior in machines. Therefore, the great challenge of research in AI, since its inception, can be synthesized with the inquiry made by Minsky in his book Semantic Information Processing, almost 30 years ago: How to Make Machines Understand Things. Thus, while the IA area to be studied academically since the 1950s, only recently it has generated a growing interest because of the emergence of practical commercial applications. A decisive factor for the success of this transition from academia to industry are the huge technological advances of computer equipment over the last 2 decades. An AI system is not only capable of storing and manipulating data, but also the acquisition, representation, and manipulation of knowledge. This manipulation includes the ability to deduce or infer new knowledge, new relationships on facts and concepts, from the existing knowledge, and uses methods of representation and manipulation to solve complex problems that are often non-quantitative in nature. One of the most useful ideas that emerged from research in AI is that facts and rules, declarative knowledge, can be represented separately from the decision algorithms, procedural knowledge. It had a profound effect on both the manner of addressing the problems scientists, as in engineering techniques used to produce intelligent systems. Adopting a particular procedure, inference engine, the development of an AI system is reduced to obtaining and coding rules and facts that are sufficient for a particular problem domain. This encoding process is called knowledge engineering. So the main issues to be outlined by the designer of an AI system are acquisition, representation, and manipulation of knowledge, and a control strategy or inference engine that determines the items of knowledge to be accessed, the deductions to be made, and the order of steps to be used. Figure 1 depicts these issues, showing the interrelationship between components of a conventional system IA. The first knowledge-based expert program was written in 1967. Called Dendral, he could predict the chemical structures of unknown compounds based on analysis routines. Subsequently, expert systems based on more sophisticated rules have been developed, notably the program Mycin. It uses derivatives rules of the medical field to reason, deduct, from a list of symptoms of a particular disease. Many researchers now believe that AI is a key technology for the future of software. Research in AI is related to application areas involving human reasoning, trying to imitate him, and making inferences. These areas of application are included in the AI settings include, among others, expert systems and knowledge-based systems, intelligent systems, learning, understanding, translation natural language, understanding, voice generation, image analysis and scene in real time, automatic programming. Therefore, it can be said that the AI field aims the continued rise of the intelligence of the computer, searching for this, also the phenomenon of natural intelligence. To this end, AI is defined here as a collection of computer techniques supported by emulating some capabilities of human beings. This collection includes troubleshooting, natural language understanding, vision and robotics, expert systems and knowledge acquisition, knowledge representation methods. The hope of major future breakthroughs in AI depends on several factors, such as growth in the number of scientists involved in the research and advances mainly in the areas of computer science, including parallel processing and cognitive science. Ethical dilemmas of artificial intelligence. Since all this work is in development for so long, I asked him about the ethical dilemmas that computers may face. We've talked about it with issues that a professor at Stanford is doing. The subject is so important that it was Technocast 033 theme entitled Scheduled to Kill. Imagine that there is an accident that the car cannot avoid, such as a pedestrian group, including a mother with a stroller, that went through a red light on a track of relatively high speed. The car cannot brake in time, so what should he do? Achieving the smallest object that can be a stroller or a grocery store, steer sharply and risking the life of the driver? The lives of those who should be prioritized, the driver or pedestrians? These dilemmas certainly have gone to the head of the drivers who made the decision in the heat. In the event of a tragedy, it is possible until the driver is not convicted because he may not have had time enough to think of the most appropriate decision. With autonomous cars, the excuse does not work. Just think of the carbon nanotubes, structures that come close to our biology and may be the future of the cores of computers. The fear that a machine can overcome the human does not mean that humanity needs to be a reference to artificial intelligence. Other beings who have no neurons, like amoeba, bacteria, can also have artificial intelligence. I work with a model that is the bacteria language. Bacteria talk to each other by quorum sensing. Changing this paradigm of view, we have other interpretations of the human healing model. Just compare the model neurons with lichens, an association between a fungus and an algae, or cyanobacterium. We are talking about intelligent beings that will be connected to each other and form a collective intelligence. And they are smart as a group. Like a neuron, one alone is not smart, but 100 billion is. Chapter 4. 10 Awesome and Terrifying Advances in Artificial Intelligence. Stephen Hawking, Bill Gates, and Elon Musk have something in common, besides wealth and intelligence. They are all terrified of a possible revolution of the machines. Also known as the apocalypse of artificial intelligence, this is a hypothetical scenario where artificially intelligent machines become a way of life, life or not, dominant on Earth. It may be that the robots rebel and become our masters, or worse, they can exterminate humanity and claim the land for themselves. But this apocalypse of the machines can happen in the real world? What made respectable and world-famous people like Musk and Hawking express their concern about this hypothetical scenario? Can Hollywood films like Terminator be right after all? Let's find out why so many important people, even leading scientists, are concerned with the evolution of artificial intelligence and why it could happen very soon. 10. They are learning to deceive and cheat. Lying is universal behavior. Humans do it all the time, and even some animals, such as squirrels and birds, use lies as a resource for survival. However, lie no longer limited to humans and animals. Researchers at the Georgia Institute of Technology have developed artificially intelligent robots able to cheat. The research team, led by Professor Ronald Arkin, expects its robots can be used by the military in the future. Once perfected, the military can deploy these intelligent robots on the battlefield. They can serve as guards to protect supplies and ammunition of the enemy. By learning the art of lying, these robots can gain time until reinforcements can reach, changing their patrol strategies to deceive other intelligent robots or humans. However, Professor Arkin admits that there are significant ethical concerns about his research. If your leak discovered outside the military environment and fell into the wrong hands, it could mean a catastrophe. 9. They are beginning to take our jobs. Many of us are afraid of those robots movie killers, but scientists say we should be more concerned with the less terrible, but still frightening, elimination of our work machines. Several experts are concerned that advances in artificial intelligence and automation could result in many people losing their jobs to robots. In the United States, 250,000 robots already perform work that humans used to do. What is more alarming is that this number is increasing by double digits every year. And it is not only the workers who are concerned with machines that perform human work. IA experts are concerned too. Andrew Ng, the brain project of Google and chief scientist of Baidu, the Chinese equivalent of Google, have expressed concerns about the danger of advancing artificial intelligence. Intelligent robots threaten us, he said, because they can do almost everything better than almost anyone. Very respected institutions also launched studies that reflect this concern. For example, Oxford University conducted a study that suggests that the next 20 years, 35% of jobs in the UK will be replaced by robots artificially intelligent. 8. They are beginning to become more intelligent than human hackers. Automated robot journalism. Hollywood movies often portray hackers as forces of law and legal sexy. In real life, it is not so. Hacking can be boring in real life, but in the wrong hands it can also be very dangerous. What is more dangerous is the fact that scientists are developing hacking systems with highly intelligent artificial intelligence to fight evil hackers. In August 2016, 7 teams are set to compete in the Cyber Grand Challenge, DARPA. The goal of this contest is to present hackers' robots superintelligent, able to attack the vulnerabilities of enemies and, at the same time, find and arrange your weaknesses while protecting its performance and functionality. Although scientists are developing robots hackers for the common good, they also recognize that, in the wrong hands, your super hacking systems could trigger chaos and destruction. Just imagine how dangerous it would be, an artificial intelligence to take control of these intelligent, autonomous hackers. We would be at least helpless. 7. They are beginning to understand our behavior. Facebook is undeniably the most influential and powerful social media platform today. For many of us, it has become an essential part of our routine. But each time we use Facebook, we are interacting unknowingly with artificial intelligence. Mark Zuckerberg has explained how Facebook is using artificial intelligence to understand our behavior. The understanding how we behave or interact with things on Facebook, the AI can make recommendations on things we might find interesting or that serve to our preferences. Zuckerberg has the plan to develop artificial bits of intelligence more advanced to be used in other areas, such as medicine. For now, Facebook's IA is only able to recognize patterns and has a supervised learning. But it is anticipated that, with the resources of the social network, scientists end up reaching IA's superintelligent, able to learn new skills and improve themselves, something or that could improve our lives and lead us to extinction. The line seems to be fragile. 6. They will soon replace our lovers. Many films, such as Ex Machina and She, have explored the idea of people falling in love and having sex with robots. But is that it could happen in real life? The controversial answer is yes, and it will happen soon. Dr. Ian Pearson, Futurist 1, released a shocking report in 2015 saying that the human sex with robots will be more common than the old sex between humans in 2050. Pearson led the report in partnership with Bondara, one of the shop's sex toys UK leaders. The report also includes the following forecasts. In 2025, many wealthy have access to some form of artificially intelligent robots' sex. In 2030, the common people will be involved in some virtual sex in the same way people casually watch porn movies today. In 2035, many people will have sex toys that interact with the virtual reality of sex. Finally, in 2050, the human sex with robots will become the norm. Of course, some people are against artificially intelligent robots' sex. One is Dr. Kathleen Richardson of De Montfort University in the UK, an ethicist in robotics. She believes that sexual encounters with machines will create unrealistic expectations and encourage misogynistic behavior towards women. It is a tough scenario to imagine. 5. They are starting to get very similar to humans. It may seem like an ordinary woman, but it is not. Yang Yang is an artificial intelligence machine that will gladly shake his hand and give her a warm hug. It was developed by Hiroshi Ishiguro, a specialist in Japanese robots, and Song Yang, a professor of Chinese robotics. Yang Yang had their appearance based on Professor Yang. Yang Yang is not the only robot that looks strangely like a human. The Nanyang Technological University of Singapore, NTU, has also created its version of the human robot. It's called Nadine and is working as a receptionist at NTU. Besides having a beautiful black hair, soft skin, Nadine can also smile, meet and greet people, shake hands, and make eye contact. What is even more amazing is that it can recognize guests and talk to them based on previous conversations. As Yang Yang, Nadine was based on his creator, Professor Nadia Thalmann. 4. They are beginning to feel emotions. What separates humans from robots? Is it the intelligence? No, robots with artificial intelligence are much smarter than us. Is it the look? No, scientists have developed robots that are very similar to humans. Perhaps the only remaining quality that sets us apart from IAs is the ability to feel emotions. Unfortunately, many scientists are working ardently to win this final frontier. Microsoft's East Asia Experts Group created a program, software, artificial intelligence that can feel the emotions and talk to people in a more natural and human. Called Xiaoice, this IA answers questions like a girl 17 years old. If she does not know the subject, you can lie. If it picks up, you can get angry or ashamed. Xiaoice can also be sarcastic, evil, and impatient, qualities which we can all relate to. The unpredictability of Xiaoice allows you to interact with people as if it were a human being. For now, this IA is a novelty, a way Chinese people have fun when you're bored or lonely. But its creators are working to improve it. According to Microsoft, Xiaoice already entered a self-learning and self-growth in a loop and will only get better. Who knows? Xiaoice could be the grandmother of Skynet. 3. They will invade our brains. Would not it be amazing if we could learn French in a matter of minutes, just by simply downloading the language in our brains? This seemingly impossible feat can happen shortly. Ray Kurzweil, futurist, inventor, and Google engineering director, predicts that by 2030, nanobots implanted in our brains make us like God. Tiny robots inside our heads will make us able to access and learn any information in minutes. We might be able to file our thoughts and memories, and it would be possible to send and receive emails and photos directly into our brains. Kurzweil, who is involved with the development of artificial intelligence in Google, believes that by nanobots' deployment inside our heads, we become more human, more unique, and even more like gods. If used the nanobots properly, it can do amazing things, such as epilepsy, or improve our intelligence and memory. But there are also dangers associated. For starters, we do not clearly understand how the brain works, and have nanobots implanted inside is perilous. But most important of all is that, since these nanobots would connect us to the Internet, a powerful AI could easily access our brains and turn us into zombies under his control, ready to rebel or destroy humanity. 2. They are beginning to be used as weapons. To ensure military advantage over China and Russia, the Pentagon proposed a $12 billion budget to $15 billion for the year 2017. The U.S. military knows that to stay ahead of their competitors, they need to explore artificial intelligence. The Pentagon plans to use the billions that will ensure the government to develop deep learning machines and autonomous robots alongside other forms of new technologies. With this in mind, it would not be surprising if, in a few years, the military is using killer robots with artificial intelligence on the battlefield. Robots can make functional brains. Use IAs during wars could save thousands of lives, But combat arms who can think and operate on their own pose a great threat too. They could potentially kill not only enemies, but also military personnel, and even innocent people. It is the danger that 1,000 experts in artificial intelligence and renowned scientists want to avoid. During the International Joint Conference on Artificial Intelligence, held in Argentina in 2015, they signed an open letter which prohibits the development of autonomous weapons and artificial intelligence for military purposes. Unfortunately, there is not much that this card can do. We are now at the beginning of the third armaments revolution, and whoever wins will become the most powerful nation in the world, and perhaps the greatest catalyst of human extinction. 1. They are beginning to learn what is right and what is wrong. In an attempt to prevent the rise of the machines, scientists are developing new methods to enable machines to discern right from wrong. In doing so, experts expect that they will become more comprehensive and humane. Murray Shanahan, professor of cognitive robotics at Imperial College London, believes this is the key to preventing machines to exterminate humanity. Led by Mark Rydell and Brent Harrison of the School of Interactive Computing at Georgia Institute of Technology in the United States, researchers are trying to instill ethics in human AIs through the use of stories. It may sound simplistic, but it makes a lot of sense. In real life, we teach human values to children by reading them stories. AIs are like children. They do not really know the difference between right and wrong, or good and evil, until they are taught. However, there is also great danger in teaching human values artificially intelligent robots. If you look at the annals of human history, you will find that, although they are taught about what is right or wrong, people are still able to produce an unimaginable evil. Just look at Hitler, Stalin, and Pol Pot. If human beings are capable of so much evil, which prevents a powerful AI do the same? Another possible scenario is that some AI understands that we are doing harm to each other, and therefore must be controlled. Another super IA may notice that humans are bad for the environment, and therefore our existence is being harmful, and we should no longer exist. Conclusion. Artificial intelligence, a danger to humanity? In 2014, Stephen Hawking said that artificial intelligence can wipe out humanity. The physicist said that as the system becomes more intelligent, we can get into danger. But some experts do not believe in this thesis, and come to compare this theory with something more serious. Do you think the AIDS virus enters your immune system and kill you now? No, because if you die, he dies together. Think of me. The models are also smart. If the virus will survive in this new environment, and it survives only if you also have live, only a fool would kill its host. They do not see the relevance of these issues that artificial intelligence can put the human race at risk. People need to open up the mind. If you think only the downside, you only build negative things. Many scientists prefer to think that gives to improve many problems of humanity with artificial intelligence, as his contributions in medicine. We still think the developments of science and technology as villains in society, something violent, because we can only think of violence. When we are trained to think of balance, happiness, lightness, we will build the same paradigms thinking of good things.